This video is for section 1-3, order in the set of real numbers. The first vocabulary word is real numbers. The set of all positive and negative numbers and zero are called real numbers. Now, every real number corresponds to a location on the real number line. So here on the screen you see a picture of a real number line with several numbers located. The point that's associated with a number is called its graph. Conversely, the number associated with a point is called its coordinate. Here's an example. In the above figure, graph all of these numbers. We're going to put dots at the correct location for these different numbers. So let's locate -3 on the number line. It's here, and what you do is you draw a dot. Now -1.5. Here's -1. -1.5 would be halfway to the -2. So about right here. Next, 1/4. Well, here is 0. Here's a half. 1/4 is halfway in between 0 and a half. So about right here. And finally, 3 3/4. Here's 3. Here's 4 over here. Exactly halfway between is 3 1/2. And then halfway between this spot and 4 is where 3 3/4 is. So you'd put the dot right there. Those dots are the graph of those 4 numbers. Many assumptions are made about real numbers. These assumptions are called axioms or postulates. Axioms and postulates are accepted as true without proof. They're accepted because they are common sense. Let's look at some axioms. The first is the axiom of comparison, and see if this sounds like it makes sense to us. If A and B are real numbers, then only one of the following can be true. A is less than B, A is equal to B, or A is greater than B. Does it make sense that only one of these can be true? For example, if A is 3 and B is the number 4, then what's true is 3 is less than 4. Or if A was 6 and B was 2, then what's true is 6 is greater than 2. This is a good time to review the different inequality symbols used in algebra. This one right here, which points to the left, is the is less than symbol. When you see it, you speak is less than. This one right here, which points to the left and has an extra line under it, is the is less than or equal to symbol. This symbol here, which points to the right, is the is greater than symbol. And the last one is the is greater than or equal to. It's important to memorize the meaning of these symbols so that when you see it, you instantly speak the correct thing. And it's certainly possible to do that, because if you can learn to see this symbol and say equals, then you can learn what to say for these 4 symbols. Any subset of the real numbers can be pictured by graphing a set of points on a number line. And it's useful to picture sets of numbers because it helps to have that visual illustration of the numbers. Here's an example. Graph the following sets of numbers. The set of numbers t such that t equals 1 or t equals negative 1. T can be equal to 1, so you put a dot at 1, or t can be negative 1, put a dot at negative 1. That pair of dots is the picture of this statement. Question B, graph the set of numbers x such that x is greater than 2. There are a lot of numbers greater than 2. To show them quickly, there's a technique we use for graphing. It involves putting an open dot on 2 and then drawing a heavy line over all of the numbers that are greater than 2, such as 3, 4, 5, and so on. You can then color in the arrowhead to show that it keeps going to the right. By using an open dot on 2, that indicates that 2 is not an answer to that open sentence. Question C. Graph the set of numbers y such that y is less than or equal to 0. A quick way to show all of those numbers is to put a closed dot on 0 and then to draw a heavy line going to the left. You can then color in the arrow to show it continues forever. We have shaded over an infinite number of points, and every one of them is a solution to that open sentence. Next, let's discuss another axiom. This one is the transitive property of order. Let A, B, and C be any real numbers. Then the following two statements are true. If A is less than B and B is less than C, then we could say that A is less than C. Is that common sense for you? Let's think of an example. Let's say A is the number 1, B is the number 3, and C is the number 10. 1 is less than the 3, and 3 is less than the 10. Therefore, the 1 is less than the 10. Common sense? The other true statement is, if A is greater than B and B is greater than C, then A is greater than C. The transitive property of order leads to the following combined form. When A is less than B and B is less than C, we could write that B is between A and C. Think about this and make sure that you agree it has the same meaning as this statement here. Next, let's do a couple more example graphs. Graph the set of numbers x such that x is between -2 and 3. A quick way to show this is an open dot on -2 and an open dot on the 3, and then to shade all numbers that are between them. This picture corresponds to this algebra statement. Question B, graph the set of numbers x such that -2 is less than x, which is less than or equal to 3. This statement is a lot like the last one. The only thing different appears to be that extra line under the symbol. Here's the graph. An open circle on -2, a closed circle on 3, and then shading everything in between. This picture corresponds to this algebra statement. Hopefully you're noticing how this number and this number are the endpoint dots, and how a symbol without an extra line on it creates an open dot, whereas a symbol with the extra line on it creates a closed dot. Now question C, write an inequality for the graphed set of numbers. There is a dot at -4 and a dot at 2. They are closed dots, so the symbols have the extra or equal to lines on them. And the shading is in between those dots, so the letter X is written in between those numbers. Here is the inequality that corresponds to that picture. Let's summarize. In this lesson, we discussed assumptions that mathematicians make about numbers. The assumptions are called axioms or postulates. We also reviewed the use of is less than or is greater than symbols and discussed how to make graphical representations of statements by putting dots and shading on a line.